Okay, Shami, what you going to teach today?
Filling taxonomy.
Okay. You might start now. For the rest, please enable your webcam, or maybe if our teachers or our lecturer today going to ask you a question because you did not turn on your webcam. So please do now.
Right. Filling taxonomy. There's a four component classification for the parallel computer according to the Flynn. This is the one of the more widely used classification since used in 1966. The first one, single instruction, single data stream. Second one, single instruction, multiple data stream. Third one, multiple instruction, single data stream. The fourth one, multiple instruction, multiple data stream. Okay, first we look about single instruction, single data stream first. It's a serial, a non-parallel computer. Single it consists of single instruction only. Only one instruction stream is being acted on by the CPU during any one clock cycle. And this is a single data also. Only one data stream is being used. It's a deterministic execution. This is the oldest type of the computer. During the earliest type of the computer that used the tape what called tape writer as a data input and the output as a screen like a terminal console. Example like this one. Okay, for this is the diagram for the single instruction, single data stream. As we can see here, there's only one processing unit, one instruction pool inside it, and one data pool. So only one instruction, and as we can see from this diagram, according to the time, only one instruction per one clock cycle only being executed. This is the single data stream paradigm. Next one, single instruction, multiple data. It's a type of parallel computer. A single instruction, all processing unit execute the same instruction at any given clock cycle. But this time it will use the multiple data. Each processor unit can operate on different data elements. Best suited for the specialized program KECIL for high degree of regularity such as graphic and image processing, like a graphic card, because like a game. For the game one, the GPU process all the data vector of the game asset to display on the screen. So GPU has so many core, it can process at a really high speed but at a simple level. Synchronized structure and deterministic acquisition. Two variety processor array and vector pipeline. This is an example of the diagram. SIMD instruction pool. There's multiple instruction. There's a single instruction set, and the data is different in a multiple data. This is the processing unit. According to the time, for example, load A1 for the variable. All the data set is different on the each processing unit. Multiple instruction, single data stream. It's a type of parallel computer. Multiple instruction means each processing unit operate on data embedded via separate instruction stream, meaning multiple instruction, but only have the single data. A single data stream is fed into the multiple processing unit. Few, if any, example of the class parallel computer have ever exist. Some might be multiple frequency filter operating system signal, cryptographic algorithm, and such on. This is the example of the diagram. As you can see, the instruction is different on the each processor unit, but the data is still the same. Each, as we can see on the processing core, all the instruction is different, but the data is still the same. Okay, multiple instruction, multiple data stream. It's a type of parallel computer, multiple instruction. Every processor may execute in the different instruction stream, but this one also in the multiple data, maybe work on different data stream. Execution can be synchronous or asynchronous, deterministic or non-deterministic. Currently, the most common type of the parallel computer, which is what we use right now in the phone, tablet, and such on, and the laptop. This is the data paradigm for the multiple instruction data set. As you can see, every core has a different data, and every processing also every has its different section, and the data also different. Like this one, so this one has the different section and the different data. Different section, different data. That's all for today. Done.
So any question from the floor? No question. Lajunya cikgu. Tak sempat tarik nafas. Sekejap okay. Yusuf Hamid, Syakti Selan, Amir Farhan. Who want to present next? Ada ke orangnya? Muhammad Amir Farhan. They are not coming today. Syami je present ni. Let me check. Muhammad Sulhasik. Muhammad Depanis Putri Rehan. They are not coming. Takut kot nak kena mengajar. So next class they isn't also. Okay, please don't share for those already scan the QR code. Please share with others, because if I check here, there is about 8 students still not yet joining us class, and for who already joined but you still did not scan your QR code, to share the QR code after before we end our class today. So today we're going to jump to our module 3. So in the module 3, basically I already share the module in our e-learning. What we're going to learn today is under process state, process control block, and process creation and terminations. Basically, it's not too long for module 3. Again, as I mentioned, our chapter 1, 2 and 3, it's not too hard as it is more on theory. But when you come into module 4, which is when you are starting to do the open MPI, and so on, so it's going to be a little bit hard. As for your information, we're going to play around with programming. So please make sure that you're going to try a lot on doing the MPI. And I hope until today, I guess starting from our first class, I already asked you to install the MPI and OpenMP. So for those still did not install the MPI and OpenMP, please do so, because by next week we're going to start our module 4. So let me start today. If you look over here, this is the PC diagram. Under PC diagram, you can see that most of that you already learn and you already know since year 1. I guess not only year 1, as theoretically and technically you are using computer, you are using laptop every single day, so you should have the knowledge of your computer. So over here, if you look into your computer summarization, you can see that you have the basic things, which is input device. And then you're going to have your output device, and another one, you should have your processor, lastly your memory. So but in your computer architecture, you can see that there is a lot of other things that you need to know. Instead of when you want to buy a new computer, of course you need to know every single detail about your new computer that you want to buy. So basically here you can see that you have the motherboard. This is the brand otak ataupun you punya jantung punya computer. If your CPU got problem, then totally your computer cannot turn on. And you can see that under CPU, under the motherboard, you have CPU, you have the memory, you have, of course, you going to have many bus. There is a lot of bus in your computer. USB bus, PCI bus, you can see over here, SCCI bus, IDE bus, and EISA bus. And about your input output device, you have the keyboard as input. You have the mouse as input. You have the output device as the monitor. So you're going to have also the card. There is several several wait. Siapa yang join ni? Oh, Khairi. Okay, you're going to have several cards. I guess this one is just like a recap because you already learned in a lot of courses before this. Senior, you are year 1 until today. I guess you already know about network card. What else? Sound card and your graphic card and so on. So all of the card also is very important. So this is just on computer summarization on the hardware. But what you're going to do is you're going to instruct your computer in terms of software. We move to the next slide. So what you need to do before you going to do programming, before you set up your coding and so on, you need to know about process and program. What is process? What is program? So over here, you need to know the differentiation between process and program. So there is a process. Process is an instant program execution. So big difference that you can see under process and program is process is active entity, while program is passive entity. So this is the first first differentiation between process and program. So you need to know the difference because later on when you are going to do your programming, you need to know process. And then after you have process, you're going to develop a program and so on. So first process is active entity, which is a program that you execute. I give you an example. If you two user running a Word, Microsoft Word, wait. Okay, if two user are running a word processor, two processor will be created. So over here, you are running a Word, Microsoft Word. So you open two processor, which is a process, the one that active. Okay, I give you another example. Maybe you are opening your Microsoft Word one, and then parallelly you open your WhatsApp uh application, or for iOS there is WhatsApp application, but maybe you are using Windows, you open your Google Chrome, and maybe you open another which is Pen, or maybe Adobe Photoshop. So you open three uh program. So it's called as a program or application, right? And it called a process whenever you open any program, an instant program that you execute, you open, you activate it. So it called as a process. So for a program, it is a passive entity whereby it comprises a program coding, which is static entity. Therefore, a program itself is not a process. So program is not a process. Process is when you open a program. So program is a passive entity. So later on you will see a static, what is static entity, what is dynamic entity, and so on. So next, you already look into the differentiation between process and program. Now you're going to see the component of process. They are three of it. So you need to memorize these three components on process. First is program code. Second is the context of program executions. And third, which is last one, is program data. So on process, you have three big components. First, program code. Second, context of program execution. And third is program data. So you can read over here what is the program code, what is a context of program executions, like content of CPU register, other informations need by the operation system, the one that you need to write in your programming, in your coding. And then the program data, the stack, store temporary data, local variables, global variable, and etc. So in the programming, in the codings afterwards that you're going to learn, you need the program code, you need the context of program execution, you need to know the program data. This is the knowledge. But this one is one three of the components, main components in the process. So just need to remember that three only. So it's very simple. And this one is the one that I mentioned. Wait. Okay, this one is the one that I mentioned, which is this is just a recap. You have input, you have the output. You need to have the processor, the processing system. This is the processing system, which is including your CPU, and also your main memory. And another one is the storage. Okay. Wait. Okay, process state. You can see over here, there is a several state in a computing program, but you're going to learn only two process state model. So over here, process that display the current activity. So it's looking back into your process, because process is the active. Go back to previous slide. You can see over here, process is active entity. So in the process, they have three main component: program code, context of program execution, and program data. And there are several process state. So you need to learn on the process state. You already know that process is the active entity. So on a state, if you remember and you memorize back, you do some recap, state over here, process that you already learned in your digital logic subject. You learn how to draw the state diagram, isn't it? So if you still did not remember, open back your digital logic subject and look back where you learn the timing diagram and state diagram and so on. So over there, you already learn that how you going to draw the state diagram. So over here, we going to look into wait some lecture WhatsApp me. Oh, apa salah? Okay, so sorry. Over here you can see that how you're going to draw the state diagram. So in our class, in our HPPC subject, we're not going to learn how to draw the state process, but we already have the knowledge of the state diagram. So we're going to just apply it in our process state model. So over here, we know that process is active entity. And when we have the state, means that we have several state. Let's say step, like a step, which is step A, step B, step C, and so on. And on the state, it is a current, which is the current active. So when process is execute, the process will change from one state to another. So these sentences, supposedly you already understand because you already know about the state diagram. Basically, it's just a similar. So in a process, why we want to learn it? Because we're going to instruct according a programming later on. So you're going to move from one process to another, from one process to another until you reach end of your coding. Let's say you want to make a programming which is have two process. Let's say first process is wait. I want to share my screen instead of window, because when I open another application, you're not going to see. Okay, let's say you want to write a programming. First process you going to do adding. Second, you're going to do subtracting, and maybe you want to have a multiplication. So in your program, maybe you want to 1 plus 1, and then your integer will increase and adding, something like that. So this is just example. So this is one process. So one process is going to enter first. This is your first process. And when your programming are running the additions process, it means as the current state or current active state. And then after you finish these additions, of course, you're going to move to another process, which is your subtraction process. So now this will be your current state. Next, so this one is your previous state. This one is next state. So this is previous state. This is current state. This is your next state. But I guess in your digital logic, you already look into next state, right? Next state and so on. So you already know about it. So over here, let's say you are currently doing the subtracting. So you're going to know that after this, you have next state. So this is called a process state, because you have several state that you're going to do. Then changes state after an event occur. Of course, after you done the additions, you're going to change to your subtraction. After that, you're going to do your multiplication and so on. And a state transition diagram can tell what event causes a process to change. This is totally similar to what you already learned in your digital logic. Because in your digital logic, if you still remember, you are learned on how to draw the state diagram, but the difference is there is 0 0, let's say 1 1, and then 0 1 1 0. You are playing around with the binary terms, but in your in your in your HPC subject, of course you're not going to look into 0001 and so on, but it is more in the process. So let's say previously you have digital logic subjects. If you have 00, when you want to change to next state, maybe you have the event cost. So you have the event cost. If your input is 1, then you're going to go to the next state of 1 1. If your event cost is 0, maybe you're going to go to the next state of 0 1. So this one is the event cost. Your input. What will trigger you? Apa yang buatkan you trigger from your current state, then you nak move to another state? So let's say over here, you have a current state. Your current state maybe 1 0. And when you have input of 0, which is your event cost, let's say. So you have the input 0, you're going to go to your next state, and your next state will be remain as 1 0. Something like that. This is the one that you already learned in your digital logic.
It's 10 hours.
So this is your event cost. Apa yang membuatkan you berubah from one state to another state? What will trigger you from move to another state to another state? Okay. So that is on the process state. And you're going to look into only two. One is 2-state model. Another one is 5-state model. So it's not too hard to understand it because you already look on digital logic previously. You can see it's quite similar to digital logic, only that in digital logic you have 0 1 0 1, but now you can see under two-state model you have only two state. You ada dua je state, which is not running and running. So kalau dalam digital logic, maybe it's going to be somewhere like how I'm going to delete all. Okay, maybe in your digital logic, you're going to have only two state, which is 1 and 0. So first of all, maybe there is something that trigger you, maybe input 1. So you will enable your process over here. When you have input 1, you are direct go to, let's say, 1. 1 is maybe not running. And then after that, you have something, let's say input 0. Then you have there is an input 0, then it going to be a next step which is running, and then it will be exit, which is your result. So this one is also maybe when you have 0 and you can back to 1 with a new event, something like that. Of course, over here it is a dispatch. And same goes to over here, you have pause, but maybe you have input 0 from 1 to 0, then until exit. So this is basically not too hard to understand because this state diagram you already learned in digital logic, and now you look into two-state model. You have running and not running. Simple, right? So senang je nak ingat because two-state model have only two. Not running and running. Itu je. Kalau you tukar pula tiba-tiba jadi not apa apa-apa je lah. So senang nak ingat. So it is between not running and running only. And your state transition diagram is like enter, and then after that you have not running, and you have this page which is running, and you have between that is pause, and lastly exit. And over here you're going to see the difference between two-state diagram, two-state model, and also five-state model. For five-state model, you have 5 steps: new, running, ready, waiting or block, and then exit. Itu je dia punya beza. So later on you're going to see how it look like, but before that you're going to see what is new. So new is the process is being created. Baru you create, which is you baru buat. Maybe in your programming it is new process. And then running is instruction that we execute. What is the one that execute? Maybe you are currently at adding process. So that is the instruction that are currently running. And then ready is the process is waiting to be assigned. Macam yang tadi we learn that you have adding, subtracting and multiplications. So after adding you have subtracting. So subtracting is the process that ready. Ready to wait. You wait for adding process to end. After the adding process end, then you're going to start, right? So you just wait for adding process to end first. So you are in the waiting list. And then you can have also the causes, which is waiting or block, which is the process is waiting for some event to occur. Example, input output completions. So it's quite similar to ready over here. which is process waiting to be assigned to CPU. But for waiting and blocking, it is a waiting for event to occur. So this is too much different. Assign and also wait for event to occur. And lastly, a exit. The process has finished execution. So now we're going to look into the diagram. How the diagram look like. So this is the 5-step model diagram. Kalau yang tadi tu senang je for 2-step diagram, you have not running and running. Now you have 5. First, you have new. And then you're going to have ready, running, and then exit. While you have this process, you're going to have also something called as waiting or block. This one is you need to wait some event. Let's say you have adding, and then you have this one is subtracting, and then this is adding, and maybe you have a multiplication, but the multiplication only will run if, let's say, you have the number more than 100. So something like that. If let's say your number of additions or your subtractions is more than 100, then you will trigger. So your even weight. So you will trigger waiting over here. So waiting, then your event will occur and it will continue ready and running and so on. So this is how the flow look like. So is it okay? So it's not too hard for you to uh, notice and remember it, because the diagram will be similar for all the programming. Only that what model that you going to use, whether it is 2-step model or 5-step model, depend also in equation. So next is, okay, under process, we still under process. So you can see over here, we already look into what is process, what is program. We also already look into a process state. Now we going to look into our PCB, or it's called as process control block. So please take note that each process has a PCB. So you ada several process, adding process, multiple process, subtracting process. Then each of the process has to be have the process control block or PCB. PCB store information related to a process. So what the content in PCB? There are 3 of it. So you're going to know that PCB have process identification, process state information, and lastly, process control information. So only that in the PCB. So what you need to know first is you're going to know about PCB. But what is PCB? It is a process control block, and under process control block, you're going to put it in all your process in your coding, in your programming, in your program. So PCB, the functions of PCB is to store information related your process. So let's say your addition process, your subtraction process, your multiplication process. What information have for each process? So first you're going to learn on process identification. Under process identification, you have numeric identifier that may be stored with the process control include identifier of this process, identifier of the process that created this process, which is your parent process, and another one is user identifier. This identifier, I don't want to explain more because you already learned also previously in some subject, which is you learn assembly language. That's the first subject you learn on coding and programming. So please try to look back your computer organization COA architecture subject, COA subject, you already learn on identifier. What is basically identifier? Kalau you still not remember, if you still not remember what is identifications or identifier, so please look back because this is just repetition or the recap from previous subject. So this one is process identification. So it's include the identifier of process, identifier of process that created this process, which is for parent process, and lastly user identifier. Next, what is content of PCB is the state information. First is general purpose of register. This also you already learn. You have EAX, you have EBX, you have ECX and so on. Your register in your computer. So you learn it in your COA subject also. In your first year, you already learn. So please check back. And then you have the control and status register, which is include the program counter, program state word, execution mode, and also stack pointer. So that is on our process state information. Next is our process control information. You have process state schedule information, and then memory management information, resources ownership and utilization, and lastly data structuring. So only that three component in your PCB. So if we do some recap what we have learned, which is we already look into the definitions of process and also a program. So the big difference between process and program is a process is active identity and program is passive identity. While you also look into a components of process, they are three, which is program code, context of program execution, and program data. And then you look into this one is no need to discuss anymore because this is the very basic in computing. And then you look into process state. Apa itu process state? What is the process state? You already look into, and in this process state you can divide it into two, which is two-state model and five-state model. We already look into two-state model diagram. So this is the transition diagram for two-state model. I already shows you what is not running, dispatch, running, and so on. And another one, we look into five-state model. We have new, ready, running, exits, and waiting or block. And another one, we jump into a PCB. PCB have three main component, which is identification, process state information, and another one, process control information. So only that. So any question for all of this? Any question before I proceed to our next subtopic? Any question? It easy to understand. You just need to understand the theory of all of that, because as I mentioned to you, chapter 1 until chapter 3 is more on theory. After when we will be in our module 4, then we're going to learn on programming. So if there is no question, I'm going to continue. So over here, you can see that we're going to look into operations on process. Still under process, but we're going to learn on operation. So generally, our OS, your operating system, need to provide mechanism for process creation and process termination. And this one, you can going to see what is inside. So first of all, we're going to look into the process creation. So you need to know, okay, you have window, you have iOS, maybe you also are using Linux. So all these operating system need to provide your system with the mechanism of two, which is process creation and termination. So Linux, Windows, and also your iOS, a computer and also laptop need to give you, perlu bagi you two important mechanism. First is process creation, second is process termination. So for process creation, it is a process that can create another process. A process which create another process called as parent process. So this one, I think it's not too hard. You know that your parent create you, isn't it? Something like that. Without your parent, you are not exist in this world. So something that a parent process will create another process. So that process, which is the baby process, cannot exist until you have a parent. When you have parent, then you can have a baby process, something like that. So a process can be created, can create another process. So it's called as a parent process. Only that this one no need to have two process. So one process only can create another process. Seorang je dah boleh create a baby, something like that. So if you convert it into a human, so one human can create another human. So that's why it's called parent, not parents. So ada satu je. So satu parents boleh buat satu baby, something like that. So in process, you need to know a parent process, which the one that create another process. While for the process that being created is called as a child process. It's not a baby process, but it's a child process. You are the parents, you are the child. Only that in the parent is not supposed to have two. Satu proses dah boleh buat child process. So it's easy for you to remember. No need to have, tak perlu pun kahwin. You tak perlu kahwin, you ada anak. Something like that. So in process creation, you have parent process and child process. So every new process can create another process. Child process ni pun dia boleh create another process. So this child process later on dia boleh jadi a parent process for another child process. So dia berkait dia berkait, let's say you have a parent process over here. And this parent process can be a parent for your child process. So you ada your child process. While this child process akan jadi parent process to another child process. This is child process to this parent. This is child process to this parent. But this parent also a child for another parent. Macam you jugalah. Your punya ayah adalah anak kepada another parents. You akan jadi parents and you ada children you sendiri. Your children will be your parents to another children. So it's linked to each other. Something like very similar to a human being. So kalau tak faham sangat tu pelik lah sebab this one can relate to your life. So that is on a process creation, easy for you to understand. While for process termination, a process should be terminate when a program terminate. Kalau you rasa you nak terminate, then you going to terminate, it will be terminate. So you have the process terminations. So we're going to look into deeper what is process creations. So process creation, you ada apa in process creation? You're going to have operations involved. You have a reason for creation. Kalau you nak ada baby, you nak ada children, you need to have a reason. And your operations that involve to create another process. So operations involve which assign a unique process identifier. Keep the process information in the process table. You're going to create PCV. As I mentioned, every process going to have PCV. And you're going to have allocate space for your process. Of course, if you don't have space, how come your process can be run? And then, you need to have reason. Kalau you nak ada anak, of course you nak ada reason. Same goes to in your process. You're going to see that you have a reason for creating a new process, a new child process. So let's say submissions of new batch job, a user log on your computer system created by OS to provide a service such as printing, spawned by existing process. So this is some of example a reason for a child process to be created or new process. Well, for process termination, you have the reason for termination. Kenapa you nak stop? Something like that. And also your operations in the process termination still similar. In creation and termination, you're going to have a reason and also the operation also. So example of the reason, like your program already complete, user log off, quick applications, error or fault conditions like memory unavailable, protection error, arithmetic error, and lastly parent terminations or parent requests. So this is example a reason for a terminations. And example for operations in process termination is data is written to a parent process and deallocate resources. Senang sangat you nak remember all the process, whether it is a terminations or it is a creations. So basically, it's very easy for you to memorize. Okay, let we move to another. As I mentioned, our chapter 3 is very short. So we're going to finish it by today because next week we're going to move to our programming. That's you going to have headache. Baru you rasa alamak HPC ni susah lah. Because you're going to play around with the programming. Okay. So, you're going to learn on context switching. Apa yang you going to have trigger something. Let's say you have I give you example addition and also subtraction, right? Okay, you have one process addition, you have subtraction process. What is the switching, which is the context switching, when you want to change from one process to another process, one process to another process. So you're going to switch between a process. It's called as change information when CPU is switched from one process to another. And then store the current process state for the process that leave the CPU on and it is PCB, and load the state of process 1 that is being allocated for CPU 8 PVC1. So you're going to see this one is process 0 and this is process 1. You are switching between process 0 and process 1. First, when you going to switch, mana pen saya tadi? Over here. When you going to switch from a process 0 and process 1, when you switch to here, you're going to store your current process, which is addition process, and you're going to leave your CPU and it is PCB 0. And after that, on the same time, you're going to load your process 1. Your state process 1, you're going to load and you're going to allocate it in your CPU from it PCB1. So this is what happened on your context switching, and still have there is some that you need to know under context switching, which is time taken for context switching is considered a system overhead. So while you nak switch, when you nak switch from adding to subtractions, so masa tu maybe it is 0.7 millisecond. So this time is called as overhead. So overhead, what is the time taken for context switching? You nak ubah-ubah for nak switch from one process to another, is called as overhead. And the speed varies from machine to machine depending on memory speed, the number of register that must be copied, and existing of special instruction. Of course, you will say, memanglah. So, you ada komputer yang ada memory of dia punya RAM 16 gigabyte, let's say. And you want to compare your system with the computer that have 32 gigabytes, of course the speed will be vary from machine to machine. And of course it's going to be depend on your memory, number of your register and so on. And lastly, your typical speed are few millisecond. Of course, as I mentioned also in here, it is normally millisecond. So masa-masa yang you punya dalam program you semua, you open words, you open Photoshop, all your executions of your process will be calculating in millisecond. That's why you cannot calculate by your own self. 1, 2, 3 macam tu, dah buka. No, it is millisecond. So what next? You have contact switch between two process. So this is what happened when you want to change from process 0 to process 1. So you have execute your process 0, and then when you want to switch, you're going to save. See over here, you're going to save into your PCB 0, while your process 1 is idle. So you tak akan buat apa-apa dekat process 1, is just waiting. And then you're going to reload that PCB 1 and you're going to execute. Bila you execute, which is you switch daripada P0 kepada P1, because you dah run yang P1 you ni, you punya P0 ni akan static. Di idle pula. And then after that, it called as interrupt or system call. Sebab you load another P1. And then after that, you going to save the PC1. So your PC1 will idle, but then you're going to reload back your PC0. So this is how it's look like. So please go look back this one module notes I already uploaded into your e-learning. Please understand the flow. Then you're going to understand all the switching process. When a switch, when you're going to switch a process, bila you akan buat pertukaran, you switching from one process to another process, when your clock is interrupt, when your input output is interrupt, when there is a memory fall, when there is a trap, or maybe your supervisor call which is just as file open and so on, which is another program is open. So please take a look what is the reason for you to switch to another process. And lastly, on the cooperating process. So this is the last subtopic. So cooperating process, you have concurrent process, can be independent process and cooperating process. So independent process cannot affect or be affected by execution of another process. Dia seorang aja. Dia very independent. Dia tak akan bergantung, dia tak akan jadi apa-apa. If let's say ada seorang lagi nak kacau dia ke, so because it's very independent. So it is independent process, dia tak akan effect atau affected by execution of another process. But you have the cooperating process. It can be and can be affected by the execution of another process. So ada dua ni, you going to understand it's totally different. And the advantages of process cooperations, why you need to have the cooperating process. advantage dia, you going to share information, computation speed up, modularity and convenience, which is you can edit, prints and compiling while you are doing your process. Let's say you are opening your Microsoft Word. In the meantime, also you can do a printing, right? So you do a cooperating process. That is what happened. So under another one is your concurrent execution require process communication and process synchronizations. So only that for your module 3 is very simple. But later on maybe I will put extra informations for your module 3 because it will be used in your programming later on. This is all more to theory, which is you're going to understand what supposedly happen in your programming. So any question? So if there is no question, for those who still did not scan your QR code, please do so. And the one that suppose are absent, Yusuf Hamid, you are here. Yusuf Hamid, but Amir Farhan dengan Shakti Silence tak ada dekat sini. So Yusuf Hamid, we going to finish, we already finish our module 3. So can you present and teach us module 1 and module 2? Which one that you want to teach is depend on you. Are you ready?
Doctor,
Yes?
Doctor, I haven't scanned the
Yes.
attendance document. Sorry for that.
Okay, wait. Where is Yusuf? Where is Yusuf Hamid? Macam mana dia boleh scan? Saya tengok dia tak ada dekat sini. So I'm not going to tag Yusuf Hamid attendance for today. Okay, for those who still did not scan the QR code, you can scan now. And for the rest, if there is no more question, you can leave the Google Meet. And anything I will inform in our WhatsApp group. Thank you for your participation in the class, and thank you Syahmi for your presentation. Thank you because you are ready with your slide. I'm really appreciate it.
Thank you, Doctor.
Modul tak ada. Okay, thank
Thank you,
you.
Doctor. Thank you, Doctor.
Okay, thank you.
Thank you, Doctor.
Thank you.
Thank you, Doctor.
Thank you.
Arida, thanks.
Thank you.
Terima kasih.
Thank you, Doctor.
Thank you.